called Atomic Cloak, and we're doing privacy-preserving cross-chain atomic swaps. Atomic swaps are a well-known technique that allows two parties to exchange assets on different ledgers. We add a twist to them by substituting the normal commit and reveal scheme with a Schnorr signature scheme that allows us to have two different commitments on the two ledgers so that the transactions are not directly linked. I will just showcase how our app works, and there are many more details on the README. So I have an account on MetaMask on Sepolia, and I will select a receiving address and a receiving chain. In this case, I will use Optimism Gurley. On the README, again, you can see the list of chains where we deployed our Atomic Cloak contract. I can choose the value between only three values. This is also done to improve on the anonymity, because in this way it's more difficult to link transactions by matching the values. Click on swap and sign the transaction. The front end now is sending a transaction to the chain and to the Atomic Cloak contract to open the swap and set the commitment, which we call swap ID. As soon as the transaction is mined, the backend will also open the mirror swap on the receiving chain. And as we can see here, and when that happens, then the user will have the possibility to close the swap on the receiving chain, thus revealing the secret that will allow the provider, in this case, to close the swap on the sending chain. So I will click now on close swap, and this succeeds. You notice that to close the swap, it did not sign a transaction. This is because we use account abstraction so that the sender is not linked at all to the receiving address, because it does not sign a transaction, does not need to have a prefunded external address to close the swap. The fee is just subtracted from the amount that they would receive from the swap. On top of this protocol, we also implemented a provider, a liquidity provider, so that the user always finds a counterparty in exchange for a small fee. Basically, the liquidity provider always accepts the swap from the user, and then using the graph protocol, they start monitoring the chain until they get an event that a swap was open or closed, and act accordingly. Our idea is that users can use our protocol basically in three ways. On one end, they can just perform a normal cross-chain swaps where they send the funds to the same address. In this case, the sender and receiver address would be the same, and the provider just provides liquidity in exchange for a small fee, but shortening the time that the user has to wait, for instance, if they want to move assets from over an optimistic bridge without waiting for the challenge period. Or you can use our protocol as a mixer, an in-chain mixer, where the sender and receiving account are different, but the sender and receiving chain are the same. Or you can use it as a cross-chain mixer where everything is different. We have several other measures in place to improve on anonymity. For instance, the provider batches together users operation. As I mentioned, the UI batches together by values, and so on. Just to conclude, we can now take a look at what happened behind the curtains. So this is the account that sent on Sepolia the coins initially. So you see that they created an open if, which is the function that you need to call to open a swap on the Atomic Cloak account on Sepolia. This is the Atomic Cloak account on Sepolia. And we see that first the open if was called from the user. Then this is the account of the Atomic Cloak contract, so the mirror contract on Optimism. And here we see that an open if, this account here is not verified, but this is basically an open if transaction to open the swap. After the swap has been closed on Optimism, then the provider closes the swap on Sepolia. Yeah, I hope you enjoyed our project, and there is much more to read including the URL for our web app in the README. Thanks.